Now come to the next rule. In this rule we are moving the summing point. In previous rule we are moving the take-off point or branch point. Now in this rule we are moving summing point. So the rule is shifting of a summing point from a position before a block to a position after the block. So here we need to move this summing point from a position before a block to after a block. So how we can move this summing point? So again the same rule. The rule is when we are moving any summing point or branch point ahead or before the block, we need to add a extra block in that moving path. Okay. So see the original diagram. Original diagram means upper one. Okay. So see the original diagram. So here the input signal is X. Okay. And the signal the signal of coming to the summing point is P. Okay, and if we put the value of this portion is plus, then the output of the summing point is XS plus P, and this XS plus P multiply with this gain of this block, and the output is final output is XS plus P into GS. Okay, this is our final output. Now we are going to change the position of this summing point from here to here. Okay. For this purpose, we add an extra block in this moving path. Okay. So see the equivalent diagram. See the equivalent diagram. So see the equivalent diagram. So here the input is XS, and this X is multiplied with the gain block, and here we get XG. Okay. And here we add this block in the moving path. So the value coming to the summing point is P into G, and this PG is at here the portion, here the summing point is plus, this is the plus. Okay, so this PG is going to add this XG. So after adding with XG, the output is XG plus PG, and this is the same as our original diagram. Okay, so by adding a block and keep the block gain is actual gain, we are getting the same output after changing the position of the summing point from before to ahead of the block. Okay. Now come to the next rule. Now here we want to move the summing point from a position after a block to a position before the block, which is indicated by the arrow. So same here, we add a block in the moving path and keep the block gain is reverse of the actual gain. So let's see the output of our original diagram, original diagram, the output is xg, because here input is x and this x is multiplied with the gain block xg, and the summing point signal is p, and so this p is add with this xg, so the output is xg plus p. Now we are moving this summing point from ahead to before, and to keep our output same, we add here an extra block in the moving path and keep the block gain is reverse of the actual gain. So if we keep the block gain as our actual gain, we are getting the same output after changing the position of the summing point from a position after a block to a position before the block. Okay, so in this manner we can move any summing point ahead of the block or before of the block. Now come to the next rule. Next rule is shifting of a take-off point from a position before a summing point to a position after the summing point. Okay, here we want to move the position of this take-off point before the summing to ahead of the summing, means we want to move the position of take-off point from position A to position B, which is indicated by arrow. So to need this change, we add another summing point in the moving path. So we can see here in original diagram the output is RS plus minus XS, and the branch path value is RS, because this RS signal is coming to this side only. Okay, now let's see our equivalent diagram. In equivalent diagram we are changing the position of this take-off point. Okay, and we add another summing point in this moving path. Okay, so let's see the output. So here we see the output is same as our original diagram. Output is RS plus minus XS, and the branch path value is also same RS, because here the value of the XS is plus minus XS, but in this case the value of the XS is minus plus XS. That means if the value of the X is plus, summing signal value is plus, then we put the another summing point value is minus X. So this plus X and this minus X cancel out, and only RS is coming in this path. Okay, so in this manner, if we change the position of take-off point from before to ahead of the summing point, we are getting the same output. Now coming to the next rule. Next rule is shifting of a take-off point from a position after a summing point to a position before the summing point. So here we want to change the position of summing point from position B to position A, and for this purpose we add an extra summing point in that moving path. Okay, and keep the value of the summing signal same as our actual summing signal value. Summing signal value means excess. Okay. In previous case we keep opposite of the summing signal value. Okay. So see, let's see the output. In original diagram, output is RS plus minus XS, and this output is also coming to the branch signal. Okay, branch path value is also same here. So after changing the position of this branch point from B to A, we add an extra summing point here and keep the signal value, means XS value is same as our actual summing value, means this value and this value is same. Okay, so the output of this system is RS plus minus XS, and the branch path value here only come RS, and this RS is add to this X plus this RS is only add to this plus minus XS. So this branch path value is also same as our original block diagram. So in this way we are getting same output. If we want to move the takeoff point from before, in this way we are getting the same value. If we want to move a takeoff point from a position after a summing point to a position before the summing point. Now come to the next rule. This is the interchange of consecutive summing point. Okay, so here there are two summing point, one is PS and one is HS. The value of PS is minus and the sign of HS is plus. So the output is XS minus PS plus HS. Now we want to interchange the position of HS and PS, means we will interchange the position of this summing point. That means second one is come in the first place and first one is come in the second place. Now come to the modified diagram. So here the input signal is XS, and after changing the summing point position, we get the output from first summing point is XS plus HS, and this XS plus HS coming to the next summing point and add and subtract the value of this second summing point. So the output is XS plus HS minus PS. So this output and this output, so this output and this output are same. So after interchange the summing point, we are getting the same output. Now coming to the next rule. The next rule is splitting of the summing point or combining of the summing point. So if you are having summing point like this and the output is PS minus XS plus HS, and if you want to split or combine this summing point into two summing point, then you can split. That means you can split this summing point like this. See the below picture, below diagram. This is our input signal X and this is P. Okay, after this we can take another summing point and another summing point, and the value and the signal value is hs. So let's see the output. Final output is ps minus xs and ps minus xs plus hs. Okay, so this output and this output are same. So in this manner, if we split the summing point, we are getting same output. Okay, now come to the next rule. Next rule is elimination of a summing point in a closed loop or elimination of a feedback loop. So you have already seen this type of structure in feedback discussion. So whenever you see this type of closed loop or this type of feedback structure, you replace this structure or this feedback loop with a single block. Okay, and keep the block gain is gs by 1 plus gs hs. Okay, so here we consider negative feedback, that's why the block gain is gs by 1 plus gs hs. If you consider positive feedback, then the block gain is gs by 1 minus gs hs. So whenever you see this type of structure or this type of feedback loop, you eliminate this feedback loop and you eliminate this feedback loop with a single block and keep this block gain is g by 1 plus g h. That means this is our block gain gs by 1 plus gs, and this is our output cs, and this is our input rs. Okay, so here we eliminate this whole feedback loop, or we replace this whole feedback loop with a single block. So whenever you see this type of structure, this type of feedback loop, you simply put this gain, you simply put one single block and keep this block gain is, if your feedback is negative, keep this block gain is g by 1 plus gs hs, and if you consider positive feedback, then put the block gain is gs by 1 minus gs hs. Okay, so I have so today here in this lecture I have discussed all the rule of block diagram reduction technique. Okay, so see this rule carefully. In the next lecture or next class I will give some example based on this block diagram reduction rule. So today I will stop here. Thank you.